how to calculate areas between two graphs. So I made a small picture. You can see, so you see two graphs, f and g. F is above g. So first thing you want to do is find out about the intersection points. So we have x1 and x2, and we know f is above g in this case. So it's always helpful to find out about what the function does, what the graph does. And we see f is above g, and we see f when I go with x to infinity, I see then f goes to minus infinity, and when I go with x to minus infinity, then f also goes to minus infinity. And g is the other way around. When I go to infinity with x, then I see g goes to positive infinity, and when I go with x to negative infinity, I see that g, can you see, g, the green graph, then goes to positive infinity. And the way to do it is, now you might already be able to see it in the graph. So first we calculate the area of f between those two intersection points. Then what you want to do is subtract from the area f, from this area I marked, the blue area, all this area, including this. Then you subtract the area of g, and then what you end up is, what you want is this area in the middle, right? So it's not too complicated. You just have to find out what your graph, or what the function does, where there are intersection points, and then you have to be careful to subtract the right area from the right area. That's very important. But basically the procedure is always the same. You have to find out about intersection points, and you have to find out which function is above, which function is below. It can be sometimes that you have to look at different sections, so that this is maybe one section, but the functions maybe they may have maybe somewhere here or somewhere on this side, both functions may have another intersection point, and then you have to do the calculation again in order to subtract the right area from the right area and not make any mistakes. This is basically how it works. In this case, the exercise type only has two intersection points, and it's quite easy. Then you can say, look between those two intersection points and look which function is above, which is below, subtract, and then you finish. So it's quite easy actually. So I'm going to show you how it works in the following clip. I'm going to show you how to calculate areas between two graphs. This is actually, I think, a quite interesting type of exercises. Sometimes it can be quite difficult, but usually the problem is not to understand how to calculate it, but rather to really, I'll show later in the exercise, in the example, but really not to be confused by all this procedure, but really just know what you're doing, and then just don't make mistakes with simple things like 1 plus 1, but really don't make mistakes and understand what you do. So how does it work? So first I want to introduce our example, which consists of, you might guess it, two graphs or two functions. One is called f, and it is x to the power of 2 minus 8x plus 2. The other function is g, which is minus 3x to the power of 2 plus 4x plus 3. And I thought of it how I could teach it to you in the best way, and I think 3 steps. First, think. And then second step, think more and calculate also a little bit. And what you need is intersection points. Then third step, then you have basically everything you need for the calculation, and then you calculate the area. So first think, what do I mean with think? First, you need to understand the functions which are given in the exercise. So this is the exercise. Calculate the area which is in between those two graphs. And just by looking at the functions, you see that, okay, this is some sort of parabola to the power of 2, and this also is some sort of parabola, but this is a parabola which is, how to say, you see it because a normal parabola looks something like this. I mean, it could be that it's maybe up here, it could be that it's up down here, or to the right, to the left, right? But usually it's always open to this side, right? Here it is open. And the thing is, when there's a minus before, in front of this expression with the x to the power of 2, then you can say it is turned upside down. So it will look exactly the opposite, so something like this in your coordinate system, right? So just by looking at it, you already know it will be, I'm sure it will be something like this. You have a parabola, maybe shifted to the right, a little bit elevated, because I see, okay, the y-axis interception is +2, so if this is +2, it goes right through it, something like this, maybe, most probably. And the other thing is, as I said, just turned upside down, that's g, but we know the y-axis interception is at 3, so if this were 3, we know, okay, most probably something like this, so we know, okay, one intersection point is negative, and the other intersection point is positive. So maybe I'm going to make a bigger picture. 1, 2, 3, 1, 2, 3, and we know f is going through here, and this looks like a regular parabola, and the other function g goes through here and is turned upside down, so most probably like this. And this we call x2 in the example, and this we call x1. x2 is the upper limit, x1 the lower limit. And we want to calculate the area which is in between those two graphs. And the way it works is we first, so maybe let's say this is f, this is g. So the way it works is first we calculate the area of g, which is the following, maybe different pen. Okay, calculating the area of g will, between those two limits, the lower limit and the upper limit, will deliver us, we will end up with something like this, right? That's what we can calculate. And the other thing is then we subtract the area between f and the x-axis. So first we calculate the area between g and the x-axis, and then we subtract the area between f and the x-axis, which is then this area. I hope you can see it a little bit. It's also sometimes with a camera not always that easy to follow those tiny graphs, but I hope you can see it, this area. And then of course we end up with the area in between, and then we got it. Then we receive what we needed. And this is how it works. Now I hope you understood the principle, right? You first calculate the bigger area, because we know g is above f. Then we subtract the smaller area, which is between f and the x-axis, and then we end up with a positive area, which is the area between the function on the top and the function below. This is basically how it works. So now we actually almost solved it, and we can always check now, whenever we have a result during the calculation, we can always check, is it reasonable? Does it fit? If I would end up with two positive intersection points, I would already know, okay, this cannot be true. And then I can always check it, and it's better. It may avoid mistakes. So first thing we just finished, we thought about it, we understood the exercise. But by the way, some interesting thing is, if you have a function maybe you were also asking why did I say it's a parabola? Because there's also something with x and something with 2. What do those things do here? And the thing is, how to look at a function is always you look at the biggest power first. And then you look at the other elements, and you always can see, okay, there's something without an x, so this will definitely be the y-axis interception. And same thing with g. So this is what you can see immediately from the function. And as I had said before, you first should always, if you want to know how the function looks like in general, then you look at the x with the highest power. And in this case it is 2. If it is 2, I know it has to be something like a parabola. And this is a regular one, and this is turned upside down, and I know the shape is maybe, because of the 3, it's a factor, so the shape, it will be smaller or bigger than the regular one. I mean, just by looking at it, I don't have to fully understand 3 by how much it will be bigger or smaller, but I just know it's a little bit different. So, first step we just did, we thought about it, which is always good. And if you have more practice, you can do this very quick. Just make a few notes, and then maybe if you then calculate wrong, maybe your teacher or professor will give you some partial credit on what you thought about. But you can show that you clearly understand the task just by drawing this picture, and then you can proceed. I think this is a good step to do. So we continue with the second step, which is intersection points. Because as I said, we first calculate the area between G and the x-axis and then F and the x-axis, but we don't calculate the entire area covered, which would be, for example, impossible with F because it doesn't intersect with the x-axis. So we first need to know the intersection points here. Those two, x1 and x2, and then when we know the points, then we can limit our area calculation. So first, that's what we're going to do. We calculate the intersection points. So we say f equals g. That's our assumption, and we want to know where. So first, we have x to the power of 2 minus 8x plus 2 is f, minus 3x to the power of 2 plus 4x plus 3. Now what we want to do is we put everything on the right side to the left side. So we say plus 3x to the power of 2. This 4x to the power of 2 minus 8x plus 2 is 4x plus 3. Minus 4x, we end up with 4x to the power of 2 minus 12x plus 2 is 3. Minus 3 is 4x to the power of 2 minus 12. 2 minus 3 is minus 1 equals 0. And then we see, okay, we have to apply the quadratic formula. And we know quadratic formula always can deliver us up to 2 results. And so we just have a look how it works. And maybe just to repeat, okay, this is called A, this is called, without, I forgot the X, this is called B, so just the coefficient, and this is called C, including the minus. And then you can just apply the quadratic formula. You should know it by heart, maybe you forget it sometimes, but make sure if this is required in an exam that you know it by heart. So it is minus b plus minus square root of b to the power of 2 minus 4ac divided by 2a. This is the quadratic formula, and everything we need, we know. We just have to put in our ABC, and then we end up with the result. So 12 plus minus b to the power of 2 is 144, and what did we miss? We missed 4ac, which is 4 times 4, 16 times minus 1, minus 16, but we have a minus here, so it will be a plus 16 divided by 2 times 4 is 8. So, whoops, x1 then is 12 plus 144 plus 16 is 160. So we have square root of 160 divided by 8, and the same for x2, just with a minus. So we have 12 minus square root of 160 divided by 8 also. And the way we now do this, the problem of all this is 160, square root of 160 is doesn't look really nice. So the thing, how we calculate it, and this is also my suggestion in the exam, then we just, if we can use the calculator, then we can just use storage. And I will use A and B for those two intersection points. So, since we cannot calculate this in our head, or maybe you can, I can't, square root of 160 divided by 8, and we end up with 3 point something. Storage A. Now it's in A storage. 3.081. Just about, not exactly. And then we say, just to make sure we stored it in A, and then, oops, 12 minus square root of 160, also divided by 8, and we end up with this value, 0 point something, minus 0.081. We store it in B. And then we know our intersection points. Then we remember the procedure. First think, that's what we did quite well. Then intersection points, we just calculate, or we just calculate the x value, which is completely enough. Then we can calculate the area. So second step, intersection points, that's what we did also quite well. We have nice results. We stored it in the calculator. Now we have everything to proceed and to do what we actually wanted to do. Always from the beginning we can calculate the area. And how does it work? First of all, we need to think about how to calculate it. And maybe you keep this little picture in mind while I show you the formal notation. So we say that the area we seek, this area between f and g, we call A. And we say the area then is the integral of, we said g is above f, so we say g, we calculate first. We calculate it between x1 and x2. And then what we are going to do is we subtract f, and also between x1 and x2. And then we end up with the area that we want to calculate. So this is the general procedure, and now we need it a little bit more concrete. So, and when we want to calculate this, of course we need to integrate f and g. So first we are going to do this, and you should remember at this point, maybe this is better, f and g, and integration you should also be able to do. So with powers, in this case, it works the following. We have to increase the power by 1 and then divide by the new power. So 1/3 x to the power of 3 minus 4 x to the power of 2. We have to increase the power, divide by the new power. So it means 8 divided by 2 is 4 plus 2x. And it's quite quick to calculate, to integrate. Now, same game. We have to increase the power. We divide by the new power, so we end up with minus x to the power of 3. Same thing. We end up with plus 2x to the power of 2. And here again, just we add the x plus 3x. So you just integrate it, and now we can put in our new functions that we just calculated in the general procedure So this is a formal notation of what I explained with the picture. So this calculations actually doesn't really look nice, but we see the result. Then it's quite, I mean, it's just straightforward. We have to put in the integrated functions here in our formula, calculate, not make any mistakes. This is the most important thing here, because it does get a little bit complicated, and then we end up with the result. So don't be confused, since it will be a little bit long. So we start with g, which is minus x to the power of 3 plus 2x to the power of 2 plus 3x between x2 and x1. Then we continue with first. What are we going to do? We need to subtract, and same thing. Now we take f 1/3 x to the power of 3 minus 4x to the power of 2 plus 2x, also between x1 and x2. And so now it becomes a little bit ugly, but it's straightforward. Just make sure that you don't make any mistakes. So we start with minus x2 to the power of 3 plus 2x2 to the power of 2 plus 3x2 to the power of 1. We don't need to write it. Minus x1 to the power of 3 plus 2x1 to the power of 2 plus 3x1 minus, now pay attention, this is important, don't forget that there's a minus, so you have to be a little bit careful. 1/3 x2 to the power of 3 minus 4x to the power of 2 plus 2 x2, now minus, I told you it's a little bit ugly, but you can do it, minus 1/3 x1 to the power of 3 minus 4x1 to the power of 2 plus 2x1. So looks a little bit ugly, but we can make it. So we can just resolve all those minuses and brackets. That's a little bit ugly at this moment, but it does get nicer. So minus x2 to the power of 3 plus 2x2 to the power of 2 plus 3x2 minus is plus x1 to the power of 3 minus 2x1 to the power of 2 minus 3x1. The minus, we know this gets a plus. We know that we need to write the minus here, and we can write a plus here, so it gets a little bit easier. Minus 1/3 x2 to the power of 3 plus 4x2 to the power of 2 minus 2x2. Now plus 1/3 x1 to the power of 3 minus 4x1 to the power of 2 plus 2x1. Wow, that's a long story. Now we start with what? We start with x2 to the power of 3, x2 to the power of 3, that's all we have, and we have x1 to the power of 3 and another x1 to the power of 3 here. So we end up with, now the x2 to the power of 3 is minus 4/3 x2 to the power of 3. Then we got that next one, and 1/3 is plus 4/3 x1 to the power of 3. Next, maybe different color. So we have x2 to the power of 2, x2 to the power of 2. We have x1 to the power of 2, and another x1 to the power of 2. And then we can calculate everything, and we end up with 6 plus 6x2 to the power of 2 minus 6x1 to the power of 2 Then we go ahead. We have 3x2, 2x2 is plus 1x2, and we end up with those two elements, which are minus 3x1 plus 2x1 is minus 1x1. So it looks actually not too ugly at this point, but of course the calculation up to this point, this is a little bit ugly, and you can make a lot of mistakes during this journey. So we just need to put it into the calculator, and we need to remember where we stored it. In our calculator, right? So x1, x2, we just put it in the calculator. Minus 4 divided by 3 times. Now, this is b to the power of 3 plus 4/3 x1 to the power of 3 plus 6 x2 to the power of 2 minus 6 x1 to the power of 2 plus x2 minus x1. And now we see the value is negative. We can, so we didn't make a big mistake, but I think there's some mistake. I will talk about it later, but the value is correct. So the value is minus 21.0819. So I think small mistake, but you see it immediately. So we didn't really calculate, but it was a small thinking mistake because I switched the borders. So when you switch the borders, you end up with a negative value, but the area itself, I mean, we calculated correctly. So of course, when you have a lot of practice, then you know about this problem or about this issue. In this case, of course, x1 should be the higher value since it's positive, and x2 is the lower value since it's negatives, and I just switched those values by accident. I didn't think at this point, but just imagine you switch x1 and x2 and then you end up with a positive value, and I can also show you that it works. So if you end up with a negative value, it's not too bad. You can still save yourself, maybe make a note or something, or correct it. We say, okay, at this point we just change x1 and x2 and then it would be perfect, and then the final result, when we put in the number in the calculator, we just write the plus here. But I can also show you, we just change the b's and the a's and we end up with the same thing, just positive value. So maybe it's quite good that I made this mistake so that you can see that it's not too difficult. You just have to understand what you're doing. You should have a little bit practice. And then actually there's not much which can go wrong. As you can see, now we have the positive value, as I said, because I switched limits, lower limit and upper limit. So in one case you end up with a negative value, and in the other case you end up with a positive value, which is actually more logic. And so in this case, I would just write maybe here, this is our x2, this is our x1. Then here I just write plus, and then everything would be fine. So this is basically how it works. You saw it's not too difficult in this part. Maybe you can make mistakes, but just practice it. Practice it. It's not too difficult. It's always the same. And if you make mistakes here, it is not due to the fact that you calculate areas between two graphs, but this is another issue. If you make mistakes here, then you need more calculating practice in general, how to deal with the brackets, how to multiply, how to deal with the minus, and always be really precise and don't forget minus and brackets, then you don't make any mistakes. But let's maybe just review the procedure. So first, think. This is always a good method. Think about what you're dealing with, and then you can lower the amount of mistakes. Maybe draw a short, brief picture very quickly so that you know, okay, this is what you're dealing with, and maybe you get partial credit if you do some mistake during this calculation. And then second step, calculate the intersection points so that you know the limits, right? Because when I want to calculate the area here, I need limits. I can't calculate everything. I need limits that I can put into my calculation. And then third step, then you can actually calculate the area. And I actually I didn't learn this formula by heart. I just remember the procedure. I draw the picture, and then I know, okay, I see what I have to do. I have a function or the graph which is above. I have a graph which is below. So of course, first I calculate the area of the graph which is above and subtract the area of the graph which is below between those two limits, x1 and x2. And ideally, x2 of course should be the bigger value, and that's where I made a mistake, but I already saw it and I know it because I did it before several times, and I know how to correct it. And I know how to correct it very quickly. I just know this mistake from practice. So when x1 is the lower value, then you can just insert everything. This is a point you have to know how to do integration. Then you can insert the functions in the formula, calculate, and in the end, I mean, if it's a value like this, then you have to use actually the calculator to insert with the storage. But it's not too difficult. The most difficult thing is, I think, first to have an understanding. So I think, let's see, we finished, we calculated the area. The most difficult thing is probably thinking, and then the final step, area, I think. Intersection points, you also need to maybe with linear functions, that is something very basic. But problem can arise area, since you have to put together both functions, you have to integrate, and first thinking, which can help you to avoid mistakes. So I hope you understood the problem, the exercise, how to calculate areas between two graphs, and thanks for watching. Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheets.com.